All right, so now we're on to part 2, where we're going to talk about concavity. Start off by talking about concavity, and we've talked about concavity before. When we're referring to concavity, this is going to be a really big topic in calculus. So our goal is just basically to understand the terms that we're using, and then we will later talk about the rules for finding these intervals, okay? So a function f is concave up on an open interval if the graph looks like a U, right? Or part of a smile. So if we look here, this is going to be our concaved up part, right? A graph is concave down. If you're trying to find part 2, I actually printed them not back and front. So it's like two pages you have to get to make up part 2.
Oh.
That looks like part 2.
Yeah.
Yeah,
That's part 3.
Part 3.
That looks like part 3 looks like it was. Go to the next slide. We just did part 2. The part 2 we just did.
Did I mislabel in my PowerPoint?
Yeah. That's part of 2, yeah.
Who knows how I label my PowerPoint? Is this part 3? We just finished part 2, didn't we? I mislabeled my PowerPoint. Ignore my PowerPoint. This is a 3. U.
Oh.
Yeah. That didn't help at all. That did not help at all. Anyways, so next we're going to know about concave down is on an open interval if the graph looks like an upside down U. I'm just going to use a squiggle line because my thing won't let me change my colors. This would be concave down. Okay. A function f has a point of inflection. Inflection or inflection? I never know how to pronounce it. Inflection, inflection. Okay. At C on an open interval if the graph changes concavity. So the point of in between where these two change, that is going to be your POI. Okay.
Would it be the direct center or would it be like that?
It would be direct center, the X in the middle. Yes, we did. That's why I said we've already talked about this. We're going to review it. So in order to find our point of concavity, our point of inflection, we're going to find the average between our X's, right? So we're going to find the average of our X's. And that's going to equal -2 plus 3 divided by 2. That's going to give me 1/2. Do we see that? Agreed? So if I get 1/2 here, that's going to be the X, and then we're going to do the same thing for the Y. So on the Y, our Y is -6 plus 4 divided by 2, and what do we get? -1. Check my math, guys. Yes, okay. So that's our POI. Hello. Are you new?
Yes.
Welcome. What's your name?
Morris.
Morris? Hello, Morris. I'm Miss Jones. These strangers are my students.
Oh my God, Amber.
He's the person you do not talk to in this class. Hello. Have a seat. I will figure out your life in a little bit. Have you been here all day, Morris? Is this your first class or you've been here all day?
No.
Oh, okay. Wait, I saw you this morning in the counselor's office. I did. You're right. I was running around like a chicken with my head cut off. All right. So here we go. We're going to practice finding points of inflection. And then we're going to label everything appropriately on the graph. Okay. Yes.
You can't find a point, you can't find a point of inflection if it's coming from infinity.
No, you cannot. There's no point of inflection if you're coming from infinity. Good job. Thank you for.
Wait, what are we doing if we find a negative one? I didn't know that.
So we're gonna approximate. So we're gonna first, let's go through and just identify, we're just labeling. Like we don't, these aren't perfect, so we're just labeling. Is that cool? Okay, so we're gonna find our terms. So we have a minimum here. We have a max here. And we have a minimum here. Okay. Your point of inflections is always gonna be one less than your max and your min. So in total, we have 3 extrema. So how many POIs should I have? It's always gonna be one less. So I should have 2 POIs. Does that make sense? We have 3 extremas. So therefore I'm gonna have 2. Am I out of those? Out of 3? Sure. We'll see where he's at. Huh? Because we have 3 points of extremas. So that means there's going to be a POI between these and a POI between these 2. Okay? You're welcome. Thank you for asking. So here are my POIs. And because I don't have exact values of an equation to work with, that's all I can do. Does that make sense? It's just label. Nope, I don't even want you to label. I just wanted you to label. That's it. Okay? Does that make sense? Now, if I knew my max and my min values, could I go through and find my POIs exactly? Yeah. Yes, but do we know them? No. All right, we're going to practice knowing them and going from there. Cool? But are we okay with the vocabulary and the labeling?
Yes.
All right, then I digress. Okay, so a point of inflection can occur at one of the 3 different places, okay? It can happen at a 0 with a multiplicity of 3, which we're going to talk about multiplicity. A multiplicity of 3 is when I'm the worst person at drawing this, but here I go. You curve through the point.
Oh, okay.
Okay, that's a curve. I need y'all to, I curve through the point. That's a multiplicity of 3. Yeah, you see my curve?
Yes. But how is it of 3?
It's a multiplicity of 3.
So all multiplicity of 3 are like.
Yes, so like if you think about the parent function for x cubed,
Oh.
that's a multiplicity of 3. Yes. Yeah.
It's the drive-by.
Yes, the drive-by. I'm gonna just do a little drive-by. I'm not stopping.
What?
I'm not gonna. Yeah. See, look, those things help, huh? Yes, we're just making a little drive-by. Our multiplicity of 3 is we're making a drive-by, okay? That's not why I said it, okay? Estimate a possible point of inflection between 2 consecutive extrema values. So that's what we just did, right? Identifying your max and your min, and then finding their halfway point, right? That's all this part is saying. Halfway point between your max and your min. And then the last one is to estimate a possible point of inflection between a 0 with a multiplicity of 3 and the closest relative extrema. Okay, so an example of that again would be me and my awkward drive-by situation, and then another point.
So is multiplicity just the degree of?
The degree, it's how it's reacting at the 0.
So they're basically the same thing, kind of like multiplicity and degree?
It's like no, because you could have an x3, but it's not the degree, is not cubic. It's the number of your factors. Sure. So multiplicity. Now, the other multiplicity that doesn't have anything to do with point of inflection, I just want to remind you, if you have a double or an even multiplicity, remember that's where you kiss the line. It's a little, you are sitting on the x value, you don't cross it. You're just going to give it a little peck and keep going. Okay. And then the other one, or vice versa. That's when you have a double or even multiplicity.
And how does that work like with the equations, like the next thing, like how does that work?
It would only be able to be identified in an equation if it's in factored form. Remember, it has to be in factored form in order to see that. So like what it would look like as an equation would be f of x equals, let's say I had x minus 1 squared times x plus 3 squared, 3 cubed. I know that I have a multiplicity so I have a even multiplicity at x equals 1. And I have an odd or triple multiplicity at x equals -3.
That's what we learned, like the black thing. And so it's what is that related to the degree polynomial?
This right here, your multiplicity values are the values of the power of your factors. Okay, so this goes back to algebra 2 when we talked about factoring and finding the powers of your factors. And so exactly, so this is actually a 5th degree polynomial. Do you remember that from algebra 2? Yes, exactly. It's how many times does your factor repeat? They said what would an equation look like? So that's why I gave an example of what the equation would look like. No, I'm not writing it anywhere. They asked me to show them an example of what. Okay. Okay. Does that ring any bells from algebra? I'm sorry. So the hard part here is that I have to assume that we have algebra 2 knowledge, right? And so, yeah.
But I know, like, once you start saying.
Yeah. So at any point, I'm assuming that you remember something from algebra 2. Stop me and ask me, because I have to think. Okay, they know this, and then we keep going. But if you don't remember, yes.
I feel like since everyone had you last year and people are different. That's what I mean. Like, I don't know what you know, like what you taught.
Oh, you are the odd man out.
I am.
They did. Oh, yeah. Well, you had me for algebra 2 already, Anna. Okay, it's a 5th degree polynomial because you add the powers of the factors together, and that determines the polynomial. So if I just had, let's say I just had x5 plus 2x minus 1, you would tell me that this is a 5th degree polynomial, right? Because it's my highest power. But if I'm in factored form, you're adding the powers of my factors.
What if it was like x squared times x cubed?
Yeah, so if I had x squared times x cubed, it's still a 5th degree polynomial because you're adding the powers of these factors. Exactly, because when you multiply exponents, you just add them.
But you couldn't do that with x squared plus x cubed?
No, because you can't combine them because they're not the same terms. All right, but that's like assuming. Thank you for asking, because I don't want to move forward and you not remember or recall something. So I'd rather take the moment to bring back the algebra 2, highlight it, and then move forward. Okay. All right. So again, algebra 2, we learned about factoring polynomials and identifying their degree in factored form by adding the powers of the factors together. Okay. Also here, this lets us know what type of multiplicity we had at each x value. So here I have a double multiplicity, a multiplicity of 2, because the power here is 2. Does that make sense? It's an even multiplicity. That means that it's going to be kissing at 1. Okay. Here I have an odd multiplicity of 3. So that means that x equals -3 is going to just do a little drive-by. Just go through it, but not stop and hang out. Okay. All right. So that's going back to prior knowledge. All right. So here we are. We have given this graph below, we're going to find the points of inflection by one of the 3 methods. Label and identify the coordinates of all points of inflection and state the method you are using. Okay. So the first thing here we're going to do is identify what we are given. So here we are given a minimum, an extrema, right? So we have a min, and our min takes place at 0, -3, right? Agree? All right. The next thing we're given is a 0 value. So we are given a 0 value at 3, 0, but it's a multiplicity of 3. So do you see how I was doing a little drive-through, a little drive-by? So this is a multiplicity of 3 at that 0 value. Okay. So we're using, out of our rules that we have right here, we're going to use rule number 1. That's because I have a 0 with multiplicity of 3. Agree? And rule number 3. Yes, Anna.
If the multiplicity is 3, is that considered a max?
No, it's not. It's just considered a 0. a zero value. Exactly, because definition of max, gotta have that increase, then that decrease, and I don't do that. Okay, so the rules that we're gonna use, we're gonna be using rule number 1. And rule, why can't they let me teach?
Give me an answer.
Yes, please.
You gotta keep a bit.
And rule number 3. Okay? Huh? All right, so now, because of this, we're gonna find our point of inflection by using these values. Does that make sense?
Yeah.
So can we find the values in between? Can we find our POI? Yes, because we know that it applies to these rules, so we can use rule number 3 and number 1.
The multiplicity isn't a maximum, but it's still like a place and like.
Where multiplicities happens are at your zeros.
Yeah,
So they have nothing to do with your max or your min.
are we still gonna be able to find inflection?
Yes, because these are the 3 times you know you can find inflection.
Oh, okay.
Yeah. So these are the 3 times you know you can find a point of a POI. And as long as these are satisfied, then I can go forth and find it. Okay? In all honesty, you should have like enough knowledge to do.